Okay, now let's look at a couple of examples of how to multiply and or divide rational expressions. So, as our first example, let's consider the product of x squared minus 25 over x squared plus 4x plus 4 times the rational expression 5x plus 10 over 3x plus 15. Okay. Now here again, remember how we multiply regular old fractions of integers, right? If you have 2 over 3 times, let's say, 7 over 4, okay? Well, of course, one way you could go would be to multiply the 2 times the 7 and get 14 over 3 times 4, that's 12, and then try to reduce that. But that actually wastes a lot of energy and a lot of thinking, right? That's going to make some large numbers, 14, 12, too big to think about. Much, much better way to go would be to factor everything, right? So this becomes 2 over 3, those are primes, times 7, that's prime. 4 is 2 times 2. Let's cancel right away, right? Because the product of those things is simply the product across the two numerators over the product of the two denominators. And if we have canceled everything already, this is already in lowest terms. This is already reduced. Our answer is 7, 6, no question about it, and we never got a number over 10 in that calculation. Okay? We want to do the same exact thing up here. Don't multiply this binomial by this binomial and this trinomial by this binomial. If you do, the top is going to be a cubic, right? The bottom is going to be a cubic. And then you're just going to have to turn right back around and try to factor these things, and now you've made it difficult on yourself. You've worked yourself into a circle. Instead, factor. Factor this top numerator. This is a difference of squares. This is x plus 5 times x minus 5, right? Factor this guy over here. That's just 5, right? We can pull a common 5 out from both of those. 5 times x plus 2. Factor this first denominator. That's a perfect square. That's x plus 2 quantities squared, right? The first guy's a perfect square. Last guy's a perfect square. This is twice the product of the thing you squared. Factor this second denominator. Looks like, again, there's a common monomial of 3 that I can pull out. We have a 3 times an x plus 5. You're multiplying all those things together. If we wanted to, there's no reason to write it, but if we wanted to, we could write it out like this. As a single fraction. But then the very next thing you're going to do is cancel anything common, right? So do that back here. Don't worry about writing this a second time. Cancel what's common. There's a common x plus 5. There's an x plus 2, which gets rid of one of those. That doesn't look like anything else cancels. Look what we're left with. 5 times x minus 5 over 3 times x plus 2. That's the reduced factored form for this product, which is probably what we want. In some occasions you might have to expand that out. 5x minus 25, distributing the 5 across the top, over 3x plus 6, distributing the 3 across the bottom. Either one of those two things is fine. Again, in practice you'll more likely want to end up here. Okay, and we have simplified things without ever seeing a polynomial that's worse than a quadratic. And we avoided the cubics because we didn't multiply immediately. Factor, cancel, put it all together. Put whatever is left together. Okay? Now let's take a look at another one. Very similar process here. X cubed minus 1 over 2x plus 2, this time divided by x squared plus x plus 1 over x squared minus 1. Okay, now we know what division of two fractions means. It means you multiply by the reciprocal. So this problem is immediately turned into a problem similar to the one above. We have x cubed minus 1 over 2x plus 2 times the reciprocal of this. That means we just flip it. The old denominator becomes the new numerator, and the old numerator becomes the new denominator. But now we're looking at the product of two rational expressions. Don't multiply. Don't fall into that trap and multiply early, because you're just going to end up with high degree polynomials. If you multiply the top numerators here for both these guys, you end up with a quintic polynomial, a fifth degree polynomial. Down below we would end up with a cubic. That's no good if we're going to try to reduce the result. Instead, factor and then cancel. This first numerator, that's a difference of two cubes. That's certainly a cube. 1 is a cube of 1. So this would factor into x minus 1 times the first guy squared there, plus the product, plus the last guy squared. Let's do this one next. Down here it looks like we could pull out a common 2. So that's 2 times x plus 1 times, or I might just extend the bar there. It means the same thing. X squared minus 1, that's a difference of two squares. So that becomes x plus 1 times x minus 1. And down below, well, that's a trinomial. I could try to set it up as a product of two binomials, but I'd have to use 1 as the two constant terms involved, and that's not going to make this middle term work out. And so I'm worried. But then, aha, look. Do you see it? Let me just leave it as is for the moment, because I see that it's going to cancel with this. Okay, if we didn't see that, we'd have to try to factor it. And as luck would have it, this guy doesn't factor nicely. But that's not the case here. We can cancel it. Further, we can cancel a common x plus 1. That leaves an x minus 1, an x minus 1, and a 2. In factored form, then, our reduced answer is x minus 1 squared over 2. Okay? Or if you really, really want to, you could multiply that out to become x squared minus 2x plus 1 over 2. Again, either one of those is totally fine as an answer, and more often than not, that's going to be helpful if this appears in the context of a larger problem. Okay? So I'll go ahead and put a box around the last one. All right, that's all you got to do to multiply or divide rational expressions.